Giddy, if you're watching this, you're a poo-poo head.
Not funny.
Okay, that was.
You don't disrespect my friend like that.
All right. Inverses. Let's take a look. So an inverse relation. Inverse relation is when you switch the x and the y values. Okay, so basically when we switch the domain and the range. So let's look at this relation. It's a set of ordered pairs. So what would the inverse of this relation be? Yeah, so we're just going to switch this around. So it becomes 1, 3 turns into 3, 1. 6, 3 becomes 3, 6.
Inverse.
Yeah, we're going to be doing a whole lesson on not just ordered pairs, but we're going to look at how does this affect other types of graphs. Okay? So let's graph. I want to look at what's the relationship between the original relation and the inverse. So let's graph 1, 3. So here we have 1, 3, 6, 3, 0, 6, and 1, 0. Okay, so
it says 0, 1 up there. Oh my god, I'm stupid.
Wait, we're doing the first one?
So you're graphing both the original and the inverse. Okay, so I'm going to do them in different colors. So here, I'm going to use this other color. So this will be 3, 1, 3, 6, 6, 0, and 0, 1. Okay. Now, the way that inverses work, you see this line that goes right through the middle? This is the line y equals x. So if you were to take your paper and fold it along that line y equals x,
Same thing.
they map onto each other, we say. So these two go together, these two go together, and these two, and these two. And so that's how we know that we have inverses of each other. They're symmetric. We say it's symmetric with respect to y equals x.
Wait, but why
Yeah.
do we need it? What do we need to do that?
So I'm going to show you on your calculator when we graph a function and its inverse that they will be, and then we'll graph the line y equals x, that we can confirm it graphically.
No, but like what would I use that? Yeah.
To find inverses?
Like what would I use that for? Like, is what I'm asking.
Really? No. You probably wouldn't use it.
Okay.
Okay. All right. What's the domain and range of the original? Okay, so let's look at the original. 1, 6, and 0. So I'll list it as 0, 1, and 6.
I think I messed it up. Can you go back up? No, I did it right.
Okay, what's the range of the original? Well, we have 1, 6, 0, and
3,
1.
6, 1. Oh, sorry.
Or sorry, I'm sorry. I'm looking at the wrong ones. 3, 3, 6, and 0. So
3,
0.
6, 0.
Okay. So the domain inverse is going to be the range
3, 6,
of
0.
the original. So we just swap those. And the range inverse, that's our 0, 1, and 6. So these two are the same. These two are the same.
This is the last class of the day, right?
Yeah. No.
Okay. Now that's just with the set of ordered pairs. If you were in my Algebra 1 class, we did inverses where we just switched them. But that was really all we did. We just switched the x and the y value. We want to look at extending that to finding what if you have an actual graph, okay, and what's the inverse of that. So I put in these steps, which will follow along. So the first step, step 1, we're going to change f of x to y. So I'll kind of follow the steps with our first example. So I'm going to put y equals 1/2 x plus 3. That's an easy step, right? Isn't f of x the same thing as y? Yeah. All right, step 2. This is the important part. Finding an inverse means we want to switch x and y. So yeah, we're going to switch x equals 1/2 y plus 3. Step 3, solve for y. Okay, so I want to isolate y with my new equation. So that's going to give us x minus 3. And then we want to get rid of the 1/2 by multiplying both sides by 2. Don't forget to distribute, right? So we have 2x minus 6 equals y. And the last step seems like a silly one, but we do want to rewrite it with a -1. That -1 means f inverse. So I'm going to just write, f inverse of x equals 2x minus 6.
-1 is
It's just notation. It just means f inverse. We don't say f to the -1, even though that's what it looks like. Okay, so next we want to graph the function and its inverse. This is how we can check to make sure that we got the right equation. So let's start with the first one. F of x equals 1/2 x plus 3. Or y equals 1/2 x plus 3. Where are we going to start?
Why can't you just multiply the original column?
You could. You have to make sure to switch your x and y at some point, but you can multiply this. You can start multiplying by 2 anytime. There's more than one way to do
Should we
this.
graph the first one?
Yeah, so let's graph. So we go up 1 over 2. Oh, Mrs. Co have
Wait, how'd you get?
y equals 1/2 x plus 3. So I'm going to start out with the y-intercept of 3.
Oh.
And then I'm going to go up 1 to the right 2. And then I just went up 1 to the right 2. Does anybody need any rulers? Okay, so here's my line. Oops, that did not go through those points. And then I want to make my other line, which is 2x minus 6. So we're going to go down here to -6. And my slope is 2. So we're going to go up 1 to the right 2.
You went opposite, up 2 to the right.
Oh, up 2 to the right one. Did I say the wrong thing? Okay.
No, I just always do that.
Sorry. Up 2 to the right one. So notice our 2 lines. Again, if we were to fold our paper along the line y equals x, do they match up?
Wow.
So if one of them was off, then I know I made some kind of mistake somewhere. Okay? They have to, well, they should. It's okay if it was off a little bit. Are they pretty close to each other?
Yeah.
Okay, that's fine.
Wait, so for the green one, you took the y-intercept from the inverse and then graphed.
Yes. So I went down to -6, and then a slope of 2, so up 2 to the right one.
Oh, okay.
Right?
Oh, yeah.
Rise over run. Okay, now we're going to do a parabola. So first thing, and you can combine this also in the same step if you want. If you want to switch, I would probably combine these first 2 steps in one, because it's kind of like f of x is y. So again, our rule is to switch those 2. All right, now what?
Now you set it to y.
Okay, so I'm going to subtract 3.
Equals y squared.
And then we're going to take the square root of both sides. Now, this means I get plus or minus the square root of x minus 3 is equal to y. Or f inverse of x is positive and negative square root of x minus 3. Now let's go ahead and graph it. So how do you graph f of x equals x squared plus 3?
Well, you go positive.
Okay, so I'm going to go up 3.
And then you do parabola thing.
Make that U shape, that parabola.
Or you do negative.
Okay, see, now this is why I taught graphing square roots first. Because we need to be able to graph a square root to graph the inverse.
That's not how they organize that.
I agree, which is why I switched. Okay, so let's look at just, what's the square root of x minus 3? Where do we go? We go to the right 3. And then when it goes up 1 to the right 1. Does that make sense? Now there's a reason I put plus and minus. Because I wanted, right, when we take the square root of something squared, don't forget, we always, did you remember to do that today on the test? Plus or minus? Remember we practiced that bonus.
No, I know. I think I did.
Okay. So we also want to make the negative.
Wait, how do you get to those?
So again, you can make a quick little, like if I plug in 3, I get 0. If I plug in 4, I get 1. But then I'm also going to get this part of the graph this way.
Do you have to do that?
I do. Why?
Because then when it's parabola.
When you fold it, it has to completely match up. Now this one's a little skinnier, but otherwise.
Is it fine? Not like make it like make up the graph, but
Kind of make it up? Yeah. I only need like 3 points, which we have.
That's what I did.
1, 2,
Yeah, that's what I'm saying. Like, it's like
1, 2,
kind of guessing direction.
Yeah.
That's
So-
it for the homework.
Often,
Yeah, me too.
often what I do is,
Hand it over.
what I say in Algebra 2 and when you go to pre-calc, it's often knowing to make the sketch of the graph rather than making like a ton of points. It's more important that you know how to graph them quickly.
In this case, not a message to Giddy if you're still watching.
Oh, okay, at 12.
Giddy, if you're still watching, good job. Very, very good job.
You probably didn't make it as far.
We doubt it.
It's only 12 minutes and 49 seconds
Yes,
in.
attention span of 2 minutes 50 seconds. That's fine.
Starting at the 10-minute mark was pretty awkward. Sorry about
If I were him, I wouldn't have watched this. Like, I'd be impressed if you watched it.
It would be impressive. But you know, you can also like watch it like sped up and.
Or just come in bonus.
Or just come to bonus.
I watched all the videos
So
at like
much
1.5.
easier.
Exactly.
All right. How do we know if something is a function? Do you remember just like if it passes the vertical?
Of the
Vertical
Right.
line says.
Okay, this passes the vertical line test, but does this one?
No.
No. So this technically is not a function. It's the inverse of this, but it's not technically an inverse. So if
That's
you
called a 1-to-1.
this is a one-to-one because this had a function as its inverse. So we call that one-to-one. You don't really need to know that vocabulary, but we can tell if we check the original. So imagine we didn't know what this was. If we check a horizontal line test, it fails.
Yeah.
So we know this does not have an inverse function.
How does the horizontal
Wait, what?
line test work?
Okay, so it says, like, let's say I gave you this. Actually, that's a bad example. Hold on.
That would not.
This,
Yeah.
does that pass the horizontal line test?
No.
So this does not have an inverse function.
Oh.
But if I gave you that,
Yeah.
this does have an inverse
Wait, so
function.
why? So that one doesn't. So
This, okay, it's not does it have an inverse,
it's not
it
an
doesn't
inverse
have an
function.
inverse function. That's all.
Will you ask us for the inverse function?
Probably not. No, but I will ask you these two. Verifying inverses. So how do we know if two things are inverses of each other? If
Yeah, if it looks like it, those are inverse.
Oh yeah, these A is inverse because you multiply it by 3 and it's inverse.
what?
Look, look, you multiply it by 3. 3 times 3 is there. It's like
You
3
just
times a third.
multiply
Okay.
it by the ending.
But so verifying, we actually have to say f of g of x, or you could put the little circle fog. This is what Mrs. Broderick taught you, the f of g of x.
Oh, yeah.
Okay, so here's what I want to do. I want to take everywhere we see x. So I'm going to take g of x, and I'm going to substitute that in here. So it's going to be,
That's so
did you do something bad? Okay, so do you see here?
How do you write it in with the fog?
Oh, you could just write it as f of g of x. It doesn't matter. It's the same thing.
I'm gonna try to do this without listening.
Okay. So what do we want to get? We want to get x. Do we get x? Come on, Leon. What's 3 times a third? 1. So we get 1x. What happens when we multiply here? Minus 9 plus 9, which equals x. Good. That's what we wanted. Now we're going to do g of f of x.
Oh,
So now I'm going to take this and plug it into the other equation. So we're just taking turns plugging one in for the other. But we have to show both equal x in the end. So here I have 1/3
Why'd you put a check?
because we wanted to get x.
They both equal x.
They both equal x.
They both equal x. 1/3 times 3x is x. Oh, whoops. Did I put it? That was supposed to be a plus. Sorry. Plus 3 minus 3.
You say it is yes.
Just say yes. Yes.
Si, señora. Oh, I got x.
Did you get x for both of them?
Yes for the next exclamation.
Oh, you got yes for the next one too?
Oh no, just for A.
No, you're wrong.
I didn't do it.
F of g of x. Let's see what we get. It's not red bull.
It's
Is
cool.
Is this somebody's folder?
Oh yeah, that's mine. It's actually probably Josh. Yeah, I read like that.
Your diary.
Okay.
You died.
So let's get off.
Okay.
yeah, this is a short philosophy.
What happens when I square a square root?
It
It
cancels
cancels it out.
It cancels it out.
Opa.
So I have 2 times x plus 1 over 2. Well, what's going to happen with the 2's?
It's gonna go bye bye.
Okay.
Bye bye. Wait.
I'm waiting. The 2's cancel.
Oh, I see what you're saying.
And then I have x plus 1 minus 1, which just gives me x. Good. Now let's check the other. Yeah.
We're just doing f of g, then g of f, to find out if they're the same.
Yeah, we want to, well, not just the same. They both have to be equal to x.
Then if they are, then that's
If they are, then they're inverses of each other.
Wait, why don't we get to multiply by 2? Oh, because it's open.
Because we cancel. So now I'm going to plug
So
this.
basically, it just needs to equal x.
Yeah, and if you get anything other than x, then we made a mistake.
We did that over yet.
That one is wrong.
Or if they're not inverses.
He is right.
Okay, what happens here? We get 2x squared over 2. The 2's cancel. There we go. Okay. How about the last one here?
Why? It works.
There's no way
Yes.
that is.
Yes.
There's no chance. No chance.
What do you get?
This case is fine.
Let's see, f of g of x.
F of g of x.
So 2. It doesn't work.
No, it doesn't work. You can tell. You look at it, you can tell.
F of g of x.
2 like this, you see if you multiply it by 2, it doesn't equal to what it other one was.
Oh, so sorry, I forgot to write yes for this one.
So
It's a quiz.
I accidentally wrote goth and then that same equation. Is that wrong? If I just like say the wrong way, if that's on this one.
It's fine.
It's I know what I'm supposed to do.
I got x plus 7.
That is right. And so since we got,
So you don't even have to do the next.
you don't have to go the
No,
other way.
no.
If one of them is no, then we're done. Okay. The last part is use a horizontal line test
Wow.
to determine whether the inverse of each function is also a function. So this is basically, we're just going to graph this and see if it passes the horizontal line test.
It does.
Let's see.
I have to pull my calculator to watch.
You can just watch. It's
Yes.
fine. Okay, so the first one is,
Oh, that's it.
oops.
Wow, we still have like 40 minutes.
I said if we finish early.
You know, like I'm at 4 9.
How do you know if it passes? The
Oops, I forgot to.
That's the one out.
We're graphing it on the calculator.
No, I'm like, how do you know it passes?
You literally just look at it.
Yes.
Yes.
So if we look at, is it gonna? So it only crosses one point at most. So this is yes.
And the next one.
That's so the next one, yes. Is it because it's a cube? Or like, does that not
No, it doesn't matter. So
Can you
let's
give
see.
us one like that that's not cube?
I might.
Wait,
Like,
that's the
it-
straight
it-
line test?
It has to pass the horizontal line test. Oof. No, it's a
Wait, but I thought
horizontal.
It doesn't pass. It doesn't, right?
What do you mean?
Like right here. Look, right here.
No, that does.
Oh,
That's okay. It's still slanted. So here, this is x
Yeah,
cubed
like a very small step.
plus 2x minus 7.
Works.
You know what? I'm going to zoom out a little bit. Looks like yes. And that's it.
Oppa!